Welcome back. This deals with Sigfox, that is technical overview, which was being continued in the previous slide. And the Sigfox, it has a modulation bandwidth of around 100 Hz channels, and this 100 Hz channels is a ultra narrow band UNB, that is it is BPSK, that is data bus phase shift keying. And here we use more of concerned with GFK, frequency shift keying, and phase shift keyings. So all these shift keyings are good in sending out data modulation and data synchronicity. So all these areas are very important in understanding the modulations. And with the spectrum of 816 megahertz and another 902 megahertz, so all these comes under some ideas of how the spectrum is connected, and the spectrum gives a wide range of networks, and all these ranges from 3 to 10 kilometer range and up to 30 to 50 kilometer range with rural line of sight. And this range deals with more related to kilometer concerns. And data rate, it comes around 100 bits per second and up to 140 uplink messages per day with 12 byte of payload each. And this payload gives, more importantly, a good data rate over it. And it has a topology of operator owned network, that is carrier model, and no gateway to manage it. Carrier model, and it has no gateway to manage it. No gateway to manage it because the topology gives more additional care over this carrier model. And this gives with phenomenal exceptional overview of power management, that is battery power management. That is it starts with sometimes from 10 to 15 years of longevity over it, with Sigfox being the more important in this modesty. And the modesty gives very strong emphasis over it. And Sigfox networked architecture, that is in Sigfox networked architecture we have end device, that is Sigfox base, that is Sigfox base station, that is Sigfox base station, and followed by a Sigfox cloud operator. So Sigfox base station followed by a Sigfox cloud operator. So that gives a customer app, and that customer app has more importantly to deal with systems that are more relevant. And the Sigfox owns and operates the entire radio network, much like a cellular carrier. And here the customers only deploy end devices and consume data via APIs, and there is no gateway or spectrum lineage to manage all these steps. And here comes application for this, and it is a waste bin network, that is smart waste bin fill level monitoring system. And here it is a municipal waste operator fit ultrasonic fill level sensor, include public bits, and each sensor reports full percentage over the Sigfox, letting the route planners collect only pins that are actually full. That is, it has some ultrasonic sensor. So This is all deals with that smart waste bin fill level monitor method, and in this smart waste bin fill level monitor method, the things deals with ultrasonic sensor, and that ultrasonic sensor has some data. That data need to be filled, and it fills over the by 1 to 2 stays and packs, reading it into a 12 byte Sigfox framework, and where we have 30 to 40% of collection of data, and all these data gets up into a UNB uplink. That this is the nearest uplink that creates a fantastic way of observing the data that travels around 10 kilometers or more than that kilometers, and has a lifetime of 10 plus years sensor battery. And in this 10 plus years sensor battery, and we have a Sigfox cloud, and Sigfox cloud that operates through a network, and that network is a triangulated and forwarded network that has some messages of the city's callback, that is of URL cases, and things that deals with fleet dashboard, that is routine optimization software, and it actually finds out how much bins available, how much thresholds available, and how much leads it has taken to go all these through it. And we have a technical overview of this NB-IoT, and this technical overview is NB-IoT reuses existing light towers and licensed spectrums, giving it carrier graded QoS security and mobility at the cost of a month of SIM or a data plan per device. And this NB-IoT device, that is SIM and light towers and the carrier network, all these stuffs give some values for the application server, that is NB-IoT network architecture. So this NB-IoT network architecture, what are all the things it deals with? That is it has a LTE family, that is light LTE family, and licensed cellular plans, that is in-guard, guard, BARD or standalone systems, and with a range of 1 to 2 kilometer dense urban area, up to 10 to 15 kilometer rural deep inner penetration. All these steps are done by NB IoT devices, and with uplink downlink things of 250 kilobits per second, and it has a cellular device, that is E-Node B, that is carrier core network, and PSMD EDRX power supply that lasts 10-year battery life. So all these steps will give a predominant structure of using this NB IoT that reuses the LTE towers and licensed spectrums, giving it a carrier graded system, security and mobility, with that cost of a monthly SIM and data planner network. And here it is a thing which is being governed by a smart water and gas metering at carrier scale, and it has some national telecom operators like Vodafone in Europe, China, and Telecom in China, and have connected well over the 100 billion NB IoT water and gas meters, replacing manual meters reading with automated hourly reports. So all these things are done, and in smart meter we have 100 plus connectivities, and LTE we have 10 plus years to uplink all these things, and with carrier cover and billing hours, all these comes under security systems, and those security systems are a distributed method of security that assesses very important ideas to be discussed with, and all these things will be discussed in the second video, in the upcoming video. Thank you.